that, again, we specify in the current directory, find my dir, and create it in there, and hit enter. Now, if I ls my dir, I see that I have a file in there. If I type ls-l, I can see that the file in there is also owned by the root. Let's make another file. So I'm going to run the previous command. And in terminal, you can hit the up key, and you can keep hitting it, and it's going to go up, up, up from previous commands that you've entered. So I see there's two files in that directory that I want to own. As we can see right now, both files are owned by root because I've created them using the super user account. Now, what we're going to do here is a form of the change ownership binary file or command. And how we're going to do that is type sudo chown, and we're going to pass it this argument -R, which means it's recursive. Every file in this directory is going to become under the ownership of Nick. So to give a little bit about this command that we're running, because it might look confusing because there are multiple parts to it, we're running it as sudo because we currently don't have permissions to this directory because it's owned in by the root user and group, and we have no write access, so we can't change it. So we're running this command as sudo. Chown stands for change ownership. That's the program that we're running. We're passing it this argument -R to make the command recursive. If I didn't have this in this command, if it looked like this, this would change the ownership of the directory to Nick, but not the files in it. So R as an argument there, and then the user and the group that we want to assign ownership to, and then the file or directory that we are going to perform that action on. So when I hit enter, and then type LSL, we see now that I've got ownership of this directory. And if I type ls-l on my directory, we can see I've also got ownership on all of the files within that directory. So to recap, we use chown to change ownership of a file. We use chmod to change the permissions of the file. Both of these can be recursive by adding -R to the command. Then we define the specifics of the change we're making. So with chmod, it's going to be 755 or 757 or 777. This is just a bad idea if you're running a server. Never make any directories ownership 777. Files are one digit less, so 666 would be full modification ability for anybody on a file. We would never do that. 664 means the owner of the file and the group of the file have read-write access, and the public has read access. And 644 means owner has read-write, group has read, and public has read. Now, if we're using the chown command, it's going to be in the format user group. And this is going to change the ownership of whatever file we give it to that. And then the last part of each of these two commands is the file or directory that we want to have this effect on. So if I type user share, this is going to give my user all all the files in this directory are going to become under the ownership of my user and my group. Be careful when you run that because some files need to be owned by root in order to work. Typically, you're not going to be working too much outside of your home directory, but we're going to get there. There are some files you're going to need to change, especially when we set up Apache as the web server and whatnot. So thanks for watching this video. I hope it's been informative. I'll see you guys in the next video. Let's create some new files. So to create a new file, I'm going to change directory into mydir, just because it's going to be quicker to write commands. And touch is going to create files. So if you just want to create a file without like in one of the previous videos I showed you how to type nano and then the name of the file, and if the file didn't exist it would open it and create a new one. But if you just want to stay in terminal and don't want to go into a text editor, you just want to create files, you'd use touch followed by the file name. So touch, and we're going to create main.cpp. So in the previous command, let me clear this. There. So in the previous command we learned how to use the asterisk. So if I were to remove this would remove everything that has the CPP extension. Let's say I actually wanted to remove everything but leave the directory intact. We would type this. So let's get out of this directory and I'll show you how it looks from the outside. So if I wanted to remove everything but my dir, but leave my dir existing, it would be written like this. And if I run that and then run ls on my dir, we see it is empty. It doesn't have anything in it. So now we can remove my dir. Oh, right, sorry. rm-rf mydir. So you need to use the -rf to remove a directory. And there, we're back exactly where we started. So to recap on a few commands here, and I'm just going to type them out. cp is copy. The first argument takes is the file, and the second argument it takes is where you're putting it and what file name. So that's how to copy files. How to remove files, you just type rm and then the file name. Now let's say this is in a directory. You can still remove it, you just type the position of the file. Then if you want to remove all file.anythings, you do this. If you want to remove all text files, you do this. If you want to remove every file from a directory, you just do this. It's going to remove everything from that directory and leave the directory. If you want to remove the directory as well as everything in it, you would run this command. And this is remove rf and then the directory name. Now, if you want to move a file, it's just like copy, except it doesn't leave a copy where it started. So file name and then where you're copying it to. Let's say you just want to copy it to the same directory with a different name. You would do this. And we also learned the touch command. So this, you can create files and stay in terminal. So that's a neat command. So thanks for watching. What I want you guys to do before you watch the next video, I want you guys to get used to moving around in terminal. So use the commands that we've learned up to this point, excluding the package commands. Just use ls and cd and move around the file system and go explore a bit. Don't change permissions on any files you're not aware of, and don't change the ownership of them. So really I'd recommend staying in the home directory at this point. Just create some directories and move around in them, create files, move files, copy files, and get used to using Terminal in this way. It's going to make future videos a lot easier because I'm not going to go as slowly on them, and so I want you guys to be able to follow. So thanks for watching, and I'll see you guys next time. Hey everyone, thanks for joining me again. In this video we're going to be covering a few more utility commands, and then we're going to move on to more advanced stuff. So we already know how to use the following commands. And also switch user. These are utility commands. I'm not gonna throw the repository commands and package installation commands in here. These are the utility commands that we can currently use, and this gives us the ability to move around the file system in the terminal, to print things out, to modify some things in terms of file permissions, but we have a few more things to do. So let's start by listing this directory's contents. So let's look at the a.out file. Let's say I want to move that. I just want to move it somewhere. So how we do that is we will first create a folder. And so this is the first command we're going to learn here. It's mkdir. And this is an abbreviation for make directory. It's going to be followed by the directory that we want to create. So again, we can use an absolute position. If I wanted to put it user bin and then my directory, this would create an absolutely positioned directory. We can go one level up or 2 levels up and then create the directory. Or we can just say in the current directory, create new directory. Then if I run ls again, we can see new directory right here. So let's move a.out into new directory. So to do this, you're going to type mv, and this is an abbreviation for move, a.out space new directory / a.out. And what this is going to do is it's going to take this file, which is found in the current directory, move it into new directory / the same name. And we do need to provide the name. And then hit enter. Now if we run ls again, we see that a.out is no longer in the home directory. But if we run ls on the new directory, we can see it's in there. So that's how to move files. Now let's say we want to copy it somewhere else. So I have a directory that I created in a previous video called mydir. Let's rename that. So to rename it, you use the mv command. Then if I run ls again, we're going to see we no longer have a mydir, but we have a my second directory. So let's copy the a.out file from new directory into my second directory. And how we do this is with a command called cp, which is an abbreviation for copy. And the first argument we're going to give it is what file we want to work with. And then the second argument is going to be where we want to copy it to. So new directory / a.out, and then my second directory a.out, and hit enter. Now if we run ls on my second directory, we get this. We've got file and file2 from the previous videos, but now we've also got a.out. And if we list the new directory, we also have a.out. So now we've got 2 copies of that file, which is awesome. Now let's say you want to copy a file while renaming it. This is possible. So let's run copy new directory a.out, and we're going to copy it to new directory b.out and hit enter. Now if we run ls on new directory, we see we now have 2 files. And the same thing for the move command. So if you want to move a file and rename it while you when you move it, you have that ability. So as you'll notice in the move command, we do need to give it the file name as well. So essentially you are naming it. So to rename it, you would just name it something different. Well, cool. Now we've got 3 copies of the exact same file. And I'm going to move it back to my home directory, and then we're going to remove some things. So let's copy from new directory a.out back into current directory a.out, and the current directory, as we can see here, is our home directory. So we're running relative commands in here, and they're being run from the home directory. So if I hit enter here and run ls, we can see my a.out file is back where it started. So let's remove a single file, and we're going to do that. Let's change into new directory. We're going to remove the b.out file. So rm is an abbreviation of remove, and then we're going to give it our file name that we want to remove. Now be very careful when removing files, it doesn't prompt you. If you accidentally add a / to the beginning, you won't have permission. You'd have to run it as sudo, so I guess it's not that big of a deal. Hit enter. Now ls, and we can see the b.out file has been removed. Let's go back up a directory. So let's say we want to remove an entire directory. So we created new directory in this video. Let's remove it. How to do that is using the remove command, but you've got to add -rf and then the directory. If we run ls again, we see we no longer have a new directory. Interesting. Let's list my second directory there. So that's what we're going to work with. We're going to rename this directory back to mydir, just because it's quicker to type out. Alright, so we've renamed that directory here. So now what we're going to do is remove, let's remove all the text files from this directory. So we've got 2 of those, so we want our a.out file to remain. And how we do this is it's going to be using an asterisk in the command, and that means everything. And you'll see how this works in a moment. So type rm mydir / anything.txt. And what this will do is it will remove every text file from this directory. Now let's say we had a bunch of files, let's say main.cpp, main.txt, main. etc. What we would be able to do at that point is type main.star. And so the star means anything, right? So this is going to be main.anything gets removed. But for right now, we're working with 2 txt files. So star.txt and hit enter. And now run ls on my directory again. And we see that it has removed everything with the txt extension. Hey guys, welcome back. In this video, we're going to be discussing the find command and some practical uses for that command. So first off, I've got a directory here named LT. So I'm going to remove everything from that directory, and then I'm going to change directory into there. We've got nothing. So to demonstrate how we're going to use the find command, I'm just going to take a moment here and create a bunch of files with very uncreative names. So I'm going to use touch to do this. And I'm also going to create some text files in here as well. There we go. So if I run ls on this directory, we see I've got like 10, 11 files, and that's not a lot. There are going to be some times that you're going to be working in really large directories, and so you can use the find command to help navigate within those directories. But for right now, we've got basically some files that we can use this find command on. So as you can see, I've got file types of two different extensions, PHP and TXT. And you can see that some of the extensions are printed in lowercase, some are in uppercase, and some are in a combination of the two. And this is going to help you understand the different things that the find command can do. So let's say first that I'm just looking for all PHP files. So I'm going to type this. So first we've got the command, which is find. The next parameter is going to be the directory that you're going to be looking in. So we're going to put one single dot because we're going to be searching in this current directory. The next argument is going to be a flag, which is going to be type. And that's going to be followed by an F for file. And then a flag called name. And this is going to be the name of the file we're looking for. So if we just put .php, this isn't going to bring anything because there's no file with that exact name. So what we need to do is add the wildcard asterisk character, and we hit enter, and it's going to return all files with this exact extension, and this is case sensitive. So as you'll notice, it's only returned files with the lowercase PHP extension, which can be useful, but let's say that I want to find all PHP files regardless of the case. This is essentially the same command. So you're going to type find dot type is file, and instead of using name, you're going to use iname. And the I basically just means that it's going to ignore case sensitivity. So if I run this command again, you're now going to see that I'm getting all PHP file extensions, lowercase, uppercase, and a mixed combination of the two cases. So that's pretty neat. We can also do it for different file names, not just extensions. So if I were to run find in the current directory, type F, and let's use iname, and I'm going to, I've got a few files with the word file in them. So I'm going to type file and then an asterisk, and it's going to return all the different files that I've got. So you can use this in a more practical application. This is just an example, but let's go find in etc. Type is going to be F, and iname is going to be asterisk dot conf, and this is going to find all configuration files, and it is a recursive function. And so you'll notice that there's a directory here, systemd, inside of etc. that has configuration files in it, and so it spits out all configuration files. So this is useful if you're looking for all files of a certain type, but also here's an interesting thing. I'm just going to clear this out here. So now let's use the find command to find files that have a certain permission set. And so how we're going to type this command is first I'm going to type LSL, and we're going to see that all the files in this directory are read, write, read. And this permission scheme translates to the numerical value of 664. So what we're going to do is type find dot for the current directory, type, and so type can take, you don't even need to include this, so if you omit the type flag, it's just going to find files or directories. If you type -type F, it's only going to find files, and if you replace the F with a D, it's only going to find directories. We're only working with files anyway, so I'm going to throw this in there. And then we're going to use the perm argument, and we're going to 0664, because those are the permissions on this file, and what it's going to do is it's going to spit back the output, which in our case is all of these files. You can also search based on file size. So again, we're going to type find with a period for the current directory, and we're going to type size, and here you can put, for instance, anything over 100 kilobytes. You can, if you're looking for an exact file size, you can use that, or maybe 1 megabyte, anything over 1 megabyte. And so you can see how this command would be useful. It wouldn't be useful in our case right here because we've got, you know, small files. Maybe we type find, I'm not sure if this can do this, but anything under a megabyte? Cool. So you can search more than or less than, and then your search parameter. Let's clear this again. You can also use a not operator. So let's say, and this is good because you can get so far using using the find command. Let's say I wanted to find all files that have an iname of .php, which is not case sensitive, so it's going to find all of the PHP files regardless of the case that was used in the extension. But let's say I want to find all files that are not PHP. Let's say I've got a bunch of image files and text files and other, you know, JavaScript files, let's say, and I just wanted to find everything that's not PHP. What I would do is type find in the current directory, type is going to be files again, not, and then the argument iname *.php. And this is going to spit back all the files that don't fit that criteria. And so this is a really useful command. I hope I've explained it well. And there's also one more thing that I want to show you guys. For this, I'm going to clear out of here, and I'm going to change directory into the etc directory. And first I'm going to run this command, find in the current directory, type is going to be file, and let's say iname is going to be star.conf. And so the etc directory we discussed very briefly in one of the previous videos, that basically it holds configuration files for applications. And so the standard, at least what I've noticed with Linux, is that configuration files usually have a .conf extension. So if we hit enter here, we're going to see that we get a lot of things. And that's partly because it's, as you can see here, in etc/fonts/conf.avail there is a file. So this is recursive, which is pretty neat. But what if you don't want it to be recursive? Well, we can pass an extra argument here. So let's type the exact same thing. Find in the current directory, max depth is going to be 1, and then let's just follow it with type F, and iname *.conf. So now you can see that the only things that it returned, that looked a little confusing. The prompt was right here. So everything over this, that's from the last command, so it was recursive. but we controlled the depth with this one. So what you can do, you can either, go one level down, or if you want a max depth of 2, you can do that. And these are all ways of modifying the find to really hone in on what you're looking for, and you can pass multiple arguments. So let's only look for configuration files that are over 50K, and I don't know if we're going to find one. No, we're not. Let's remove the max depth so that it will be recursive, and 10K? There we go. So we found a couple. This file is more than 10 kilobytes. So again, that's how we use the find command, and this is a really powerful tool. I'm convinced that you guys, if you're using a graphical file manager, it's really not that necessary, because you can kind of look at everything and see so much more. But if you're working in terminal, I'm confident that this is going to be a command that you guys are going to be able to, hit the ground running with. This is, a really great and powerful tool. So thank you guys for watching. In the next video, we're going to be going over another really awesome command. Hey guys, welcome back. In this video, we're going to be talking about the grep command and how we can use that to find things in files. So in the previous video, we learned about the find command and how we could use that to find files. And now we're going to be covering how to find things in files. So we do that using the grep command, which you can use like this. So first, I've got a bunch of PHP files here. Let me remove these 2 files there. So I've got a bunch of PHP files here, and what I've done was I've put some functions in them. So this one has 2 functions, and the other ones have some other ones as well. And we're going to be using this to demonstrate how to use grep. So you type the command grep, and then what you're looking for, and then what files you're looking for them in. So if I were to type file2.php, this would return the 3 functions that I have in that file. If I were to just keep adding on files here, it will look through each file, and it will actually return which file they're found in. So that's pretty neat. 2 things that I want to talk about regarding grep before we do anything a little more extreme is 2 flags that it can take. So a flag in a command is a way to pass it more information about what we want to do. We can get really specific. So we're going to run grep using I, which means ignore the case. So case sensitivity won't be a problem here. And then we're going to look in all files. Oh, I forgot the search string. We're looking for function. And this finds not only the functions that we saw in the previous command, but it also found this function, which has a capital F. If we were to run the grep command without the -i on all files here, you'll notice that the only difference between the output is in file 2 here, it found function with a capital F, and it didn't in this result. So that's how you use the -i. It's pretty standard across Linux. Usually I will be integrated into commands as, ignore case sensitivity. Now the second flag I want to talk to you guys about is really neat. It's -n, and it can be used in conjunction with other flags. We're going to type the string that we're looking for and the files we're looking for it in. And what this -n flag does is it gives you the line number where the instances of the string is found, and then the rest of that line. So this is pretty cool. This is how you use grep. Let's say that I had a bunch of PHP files and a bunch of JavaScript files and other files that have functions in them, but I only wanted to look in all of the PHP files. Well, how I would do that is by using the find command. So in the previous video, we learned that we can look in the current directory for type is F for file or D for directory. And then we can give it what we're looking for. So in this case, we're going to be looking for all PHP files. And the iname flag means ignore case sensitivity in the string that we're looking for. So we found PHP files with extensions in both lowercase, uppercase, and a mixed case here. So that's cool, but how do we use find with grep? And this is going to be the big thing that I want to show you guys. This is really handy. So what you can do, you can give it a certain search through the find command. So we're going to find type F. The iname is going to be PHP. And then what we can do is we can pass the find command another flag, which is going to be exec. So what this is going to do is it's going to first find all files that match this criteria, and then it's going to execute the next command on it. So we're going to use grep function, and I'm going to pass the -i and -n flags here. And then we need to add 2 curly braces and a plus sign to end the exec flag. So everything in here is going to be executed within this flag. So if I hit enter, it's going to look through all PHP files and it's going to find case sensitive or case insensitive functions with line numbers. So that's really cool. We can use this to find type file size. We're going to say less than 10 kilobytes. And we can group search parameters here. So I just passed a flag of size, and the value of that flag is under 10 kilobytes. But I'm also going to pass it -iname, which is going to be .php. So this is going to find all .php files that are less than 10 kilobytes, and then I can exec grep in here. And right now that looks the same because I'm pretty sure all my files are less than 10 kilobytes. They don't have much in it. But you can kind of see how this works. So this is a really powerful tool, and you guys can use grep and find together to search through a very specific set of files for very specific strings and instances. One final thing that I want to show you guys in this video is how to redirect the output of a command. So how we do that is simply we write a command. For this instance, it's going to be ls. And then we're going to use the right arrow, and this is the key just to the left of the question mark key on most keyboards. And then we're going to tell it what file we want to put it into. So rather than outputting the result of ls, it's going to put the result into out file. And so we can type nano out file.txt, and we can see the output of that command, which is pretty neat. Now, I'm going to use the find command to find all files with a size of less than 10 kilobytes. And I'm going to use exec grep -i-n. We're going to look for sandwich. Then we're going to end the exec flag here. And then we're going to redirect the output to f.text. Oh, oops. Let's, forgot this, iname. We're only looking in PHP files here. There. Now, if we open up f.text, we see these two sandwich functions that I found. But that didn't print it out on the screen, so the final command that I'm going to share with you guys in this video is tee. And what this does, if I type the previous command out again, let's look for function this time. And we're going to end this. We can actually pipe this across to tee. and make an outfile.txt. So before I run this, I want to break this command down. We're using find to find all files less than 10 kilobytes in size and with a .php extension. We're then going to execute grep, ignoring case sensitivity and numbering lines. We're going to search for function in these files, and then we're going to pipe it over to t, and the second argument of this t command is the out file that we want to write the results to. And what this command will do is it will return the results on the screen, but it's also going to put them into of.txt. So this is going to be useful if you want to copy down the results of a command while seeing them in real time. So that was a pretty big video. I hope you guys found it informative, and I hope I explained it well. In the next video, we're going to be going over processes and what they are and how to manage them. Hey guys, welcome back. In this video, we're going to be talking about processes, what they are, and how you can manage them. So if you've ever opened up the task manager in Windows, you would see a list of running applications or processes. The same thing is true for Linux. Basically, a process is just an application that is running. And so we can get an idea of what kind of processes run on a Linux machine by using the command top. So if we run this, it'll show the top of the list of running applications. It's real time, so if we start new applications, it's going to see these processes in here. So I don't want to go through every single column here, but what I do want to mention are the most important things. The PID is the process ID, and you can use this to manage that process. The user is who the application is running as. And you can see how long an application's been open and also the command that's associated with the process. And as always, you can hit Control-C to escape that. So what we're going to do to see the entire list is use a command called ps aux. And this is not real time, so this captures it at the time that you run that command. But you can see the list is quite a bit larger, and we can go through and look for applications that we want to see. But this can get a little convoluted just because of how large this list can be. So I'm going to run Theory Browser here. And when it opens, this is now a process that is running. So I can find any Leary browser processes by typing ps space aux, and then we can pipe that over to the command grep, and we can look for Leary browser. And this is going to search for all processes that have Leary browser anywhere in it. So the name of the command or the file path of the command, it doesn't matter. It's going to find it based on that name. Now that's pretty neat. It gives us a few things. It gives us the process ID and the time running and the command and stuff like that. And it also gives the time that it was run. So we could use this process ID to manage whether this app is running or not. But let's say we've got a few instances running. So now I have 3 processes for the Leary browser. So what happens when I run the previous command? It's messy. You could read through this, and if you want to, but if you just want to have a quick look at it, this is not the command. If you want to get the process IDs of an application, you can use the pgrep command and type in Leary browser. And this is going to return 3 process IDs because we've got 3 processes running. The order of these process IDs is chronological. So the top one here, 6186, that's the first window I launched, which is this one. And I'm going to type first right here. This would be the second one, which would be this one. So this is second window, and then the third one we're going to put over here. And we're going to do that so that we can I can show you how you can identify processes based on chronological order if you know the order in which certain things were opened. I did because it's I only ran three instances of it, and the way that they opened, they told me which ones were on top, and so I could see the order of them. So let's say I wanted to close the second window. I can use a command called kill. So I'll type kill and then -9 and then the process ID. So in this case, it's going to be the second one, which is 6300. So if I type 6300 and hit enter, it kills that instance. So if I run pgrep on Leary browser again, it's now just going to show me the other two. Now, you can kill apps like this. 6186, and then another process ID 6358. We can run that, and it's going to kill all those processes. Now that's pretty neat, but let's say that you've got a few instances running, and you don't want to type the process IDs for each one. If I type pgrep Leary browser, this is going to return 4 process IDs. Now, in the pgrep command, the application is pgrep, and then the second parameter that it takes is the command that's run. So it's the same when we run top. We'll see under command Leary browser right here. So we can see that's the command, and if I was running it from terminal, it would be /opt/Leary Leary browser, something like that, and then the resulting command would be Leary-browser. That's the actual binary file that's running. So what we can do, rather than closing them by process ID, which we can get running this, we can close them all at once by using the kill all command. And so how to do that is basically type kill all and then the process name, which is Leary browser. That's going to kill all of those processes. So that's basically how to manage and monitor processes on a Linux machine. I hope I explained it well. In the next video, we're going to be discussing services. Hey guys, welcome back. In the last video, we discussed processes, and in this video, we're going to discuss services, which are a special type of Linux process. For the sake of this video, I've downloaded and installed Elasticsearch from elastic.co. I've tried different versions of their software, and I find that 1.7.3 works best for me. Let me just check and make sure I'm telling you guys the right thing. Yeah, 1.7.3 has worked the best for me on all Debian derivatives that I've tried it on. So if you have trouble with other versions, try installing this. They offer .deb and .rpm for installers. We're not going into depth on Elasticsearch, but we're going to use this as an example for a service. And we're going to see services more in depth in the future as well when we install Apache web server on the machine and use that. So we start a service by typing sudo service and then the service name and then the action we want to perform on it, which is start. And we get no output, but it did start, and we can confirm that by going to Firefox here and going to the web interface of Elasticsearch, which is located on port 9200 at localhost. And we see here that we are connected to Elasticsearch. So we can also stop the service in a similar way. And if we come back here, we'll see that it's unable to connect because we're no longer running that service. So a service is like a process, except you start it up and it kind of waits in the background until you need to use it, or it can perform various tasks in the background. So they're helpful to have, and they're lighter on the system when you're not using them. So let's start up that service again. Confirm that it's open. There it goes. Takes a minute to load up. And let's say that I don't want to run it on port 9200. I want to run it on port 1150. So how we do that, we need to edit a configuration file, and the Elasticsearch configuration file has a .yml extension. So I'm going to use find here to look in etc, and the type that we're going to be looking for is a file, and the I name is going to be Elasticsearch asterisk. And here it is right here. So I'm going to sudo nano etc elasticsearch.yml. And in this file, we're not going to go over the file too much, but I'm just going to find the part that configures what port it runs on, which is down near the bottom. There we go. So that's the IP address, and then the port here. There we go. So the default is 9200. I'm going to change it to 1150, then I'm going to save the file and exit. Now if I refresh this, it's still going to work on port 9200. It's not going to work on port 1150. And the reason for this is that it's still using the old configuration file until the service is reloaded or restarted. So rather than typing Elasticsearch stop and then Elasticsearch start, we can use one command, and that is sudo service Elasticsearch reload. Oh, restart, sorry. And it's going to restart the service. So now if we come back here, give it a moment, and then refresh, we're going to see that now we're connected on port 1150. And if we were to go back to port 9200, it would no longer work. And this is because the restart function has updated the configuration file that it's running with. So that's basically how you use a service, and we went through the commands that I learned when I was learning Linux, and we don't use those anymore. So Ubuntu has moved to using upstart and system control. So nowadays how we would do this, let's stop the service, is kind of in the same way. We're going to use a different program though. So I'm going to type sudo systemctl start Elasticsearch. I'm going to change the port here to 1150. So essentially, system control does the exact same thing that the service command does. It just does it a bit differently. And that's probably going to become the standard way to do it in the future. So I'd recommend it's similar to stop the service. The only difference between using service and system control is that in system control, the action is before the program or before the service name. In service, you type service, service name, and then action. So that's the only really important difference between the two. I would use system control. Get used to using that because I'm pretty sure that's what's going to become standard. Thanks for watching. In the next video, we're going to be going over scheduled tasks. Hey guys, welcome back. In this video, we're going to be discussing cron tabs or cron jobs. And this is basically a way to schedule tasks to be run at certain times. So let's get right to it. How you're going to get into the interface for building cron tabs is typing cron tab -e. And this is going to open a cron tab file that's going to be saved to the etc. directory. And I'm going to erase this. So basically, you can see on this line right here the structure of the cron tab. So this is going to be minutes, 0 to 59. This is going to be hours, 0 to 23. This is going to be day of month, so 1 to 31. Month number, which is going to be 1 to 12. And then day of week, which is going to be 0 to 6. And then the command that you want to perform at that time. So I'm going to run a command on the 15th minute, the 14th hour, regardless of the day of the month, regardless of the month, and regardless of the day of the week. And the command that I'm going to do is ls, and I'm going to output the command results to home nick lt cronres.txt. And I think if I change this to 12 and then save and exit it, we'll be able to see this happen right away. So let's go into this directory here, unmaximize it. So it's now 2:12, and we're looking for cronres. So this process just ran, and it returned a list of my home directory, and it put it into this file. So as you can see, if we go back in there, the reason it did that at this exact time is because on the 12th minute of the 14th hour, on every day of the month, every month of the year, and every day of the week, then this is performed, right? So if I wanted this to run at 5 a.m. on Sundays, I would do this. And at 5 a.m. every Sunday, it would log this, this ls command to cronres.txt. Well, that's cool, but what practical applications does it have? Well, one of them actually you can see in the example here. You can actually keep a backup updated. This is going to run at 5 a.m. every week on Sunday or Monday, and it's going to basically do this. It's going to create a tar archive here. So it's going to store it in var/backups at home.tgz, and the contents of it is going to be the entire home directory. So it's going to make an entire backup once a week of all your files. So that's pretty useful. I want to give you guys one more example of how cron tabs can be used. So I'm going to exit out of here. I'm going to hit no. And what I'm going to do now is, so when we just did that, we set up, the reason why it output my home directory for the ls command into this file is because we created that cron tab as our user. And so if we wanted to run a command in a cron tab that required elevated privileges, in order to do that, we actually type sudo cron tab -e. And this is going to open the cron tab file for the root user. So if we scroll down, perfect. So let's set up a command. So I'm going to run this at 7 a.m. Every day of the month, every month, and on Monday. So Monday morning at 7 a.m. this is going to run. Get upgrade -y. So the -y flag in the apt get upgrade basically means say yes to everything. So this command is going to keep my system updated every week at 7 a.m. on Monday. So this is great for scheduling tasks. If you need certain things to run at certain times or so frequently, you can do that using cron tab. I hope you guys enjoyed that. I'm really excited because in the next module we're going to get to talking about developer things. And so we're going to go over different development environments and technologies and stuff. So that's really exciting. Thanks for watching, and I'll see you guys next time. Hey guys, welcome back. So in this video we're going to go over integrated development environments, or IDEs as they're otherwise called. So there's a difference between a code editor and an IDE. A code editor is good for quickly editing single files or even multiple files, and they usually provide decent syntax highlighting, smart indentation, and sometimes code completion, which is a really handy tool to have. However, if you're working in a large project or need a more complete set of tools for development, you're going to want to use an integrated development environment. IDEs offer the same code features as code editors, but also more advanced features like version control support, tool chains, and ways to run the application from right in the IDE. Depending on your choice of programming language or development tools, you'll need to choose an IDE which supports those technologies. Some IDEs support multiple languages, while others choose to support only one language or select few and optimize the IDE for the chosen languages. For instance, Eclipse is a widely used IDE, provides version control support, support for many different languages from C to C++ to PHP and Java. Like many IDEs, Eclipse requires Java to be installed in order to use the IDE. To install the Java runtime in Ubuntu, open up Terminal and type sudo apt-get install openjdk-8-jre. Or if openjdk 8 isn't available in your system's repositories, you can install openjdk 7. Then extract the Eclipse archive you downloaded and run the eclipse-inst file to launch a graphical installer. CodeBlocks is another popular IDE that supports C, C++, and Fortran. Unlike Eclipse, CodeBlocks was written in C++ instead of Java, and so it doesn't require any special runtimes in order to use it. Now Qt, or Qt, is a framework for cross-platform GUI applications, and the development installation includes its own IDE called Qt Creator. Qt Creator supports C++ and QML as languages,